Let me ask you a question. Have you ever missed a call? Have you ever been hacked? I'm not impressed. Try doing them both at the same time. Allow me to explain how this voicemail is not actually a voicemail. It's actually just the first step in a multi-stage infection chain that leads to Dark Crystal, a rat. No, not that type of rat. And no, not that type of rat either. This type of rat. A remote access Trojan. Malware designed to infect your machine, create a persistent foothold, give the attacker a backdoor, and extract and exfiltrate your credentials and your data. And in this video, I'm going to fully deconstruct and analyze how this link and a voicemail that's not really a voicemail infects your computer. I observed this link being distributed via email in the wild. Users were sent an email telling them you missed a voicemail. Please download and listen to your message here. And naturally, I wanted to investigate and inspect this website. So go to it in a browser and there we go. It pops up and it's gone. And now I'm at bing.com. Pretty interesting. Maybe it was an error. Let's reload the website. There we go. Pops up, and now I'm back at bing.com. It was not an error. This is anti-analysis. This is defense evasion. Let's open a new tab, paste in the URL, but we're not going to go there yet. Control-Shift-I to open Chrome DevTools. We're going to go to Sources, Event Listener Breakpoints, and we are going to set some debugging breakpoints to analyze this website and analyze what's going on. Why can't we actually get to it? And now we can go to the website and instantly we hit a breakpoint. This website has loaded JavaScript. It's running it. Script first statement. We've paused on an event listener breakpoint that we set. If we take a look at this script is decoding and executing a giant base64 string. If we were to copy this out, and if we look at this in an editor, it has an encoded base64 string. All it does is decode that string and then write that to the document. If we zoom out and turn word wrapping on, we can see just how massive this base64 string is. And what we could do is take this entire string, copy it out and throw it into something like CyberChef and decode it so we can see script language, JavaScript, and we've got a whole nother level of obfuscated script. And you can even see they left in a comment that tells you where this code was obfuscated from. If we go to this blackhackertools.com, you can find a lot of useful hacker tools here with different functions. For example, if we scroll down, look through here, JavaScript obfuscator. And we can see how just something small, tiny command like hello world turns into this giant unreadable long string. So kind of cool to figure out what type of tools they're using. But if we go back to our website, let's keep stepping through this debugging. Let's hit play. You can see, boom, we just loaded into a new script, and this is the obfuscated script we just saw. There's the tag for blackhackertools.com. Let's keep stepping through, and boom, here we go. Now we are at a totally new script, and this is something we can actually read. So this is some more JavaScript. And in this script, they have functions to get the location, get the time, start a download process. It reaches out to another website, https filmedbyjazz.com. And down here, we can see if the email is not found, redirect to bing.com. So that is what is redirecting us, is stopping us, is because we're actually missing an email. And if we trace this back, it goes back to user email equals the URL hash substring. And the URL hash just refers to the string after the hash symbol in the URL that you're currently at. So if we keep stepping through this script, you can see there it loads a little bit. We'll keep stepping and boom, eventually we get redirected to bing.com. So let's go back. Now that we know that we're missing the URL hash email, all we have to do is put in a hash and then put in an email. For example, let's use John Smith at Amazon.com. Now when we load it, boom, there you go. You can see we actually weren't redirected You can see it updated the location, it updated the time, it updated the website to say Amazon voice message, updated the tab header to say Amazon, and it updated this little voicemail message to say John Smith. It's connected to my email, secured with Norton. Thank God, I was getting worried for a second there. Good thing we got Norton. Amazon Secure Voice Inc. So it's got a lot of different pretext, context filled out things to make users think that this is legitimate. And ultimately, they're trying to get people to download this audio message, this WAV file, this voicemail. So what happens? Let's download the voice message. Oh, connecting to Amazon servers. Awesome. Downloading from Amazon servers. And it prompts you to download the voicemail, but as we can all see, this is not a WAV file. This is not a voicemail. This is a zip file. If we were to get fooled, let's say we open up that zip, you can see this is not just a zip file, it's a VBS inside a zip file. VBS standing for Visual Basic Script. So instead of listening to our voicemail message, we're actually going to be running a script. But let's get into the malware. Let's take a look at the VBS, the first malware script that's getting ran. It looks like junk. There's a lot of hello messages, a lot of stuff that's obfuscated that does not make any sense. A lot of these random strings. We've got Chinese characters, Russian characters. A lot of this seems like it's really not doing anything. But there is one section here in the middle that actually looks a bit different. We can see different characters, but we do see they have an execute command down here, which is going to execute or evaluate or run code. Looks like they're executing this bxirp variable, which seems to be tied to these strings up above. Now this is interesting, and I want to figure out what they're doing. I don't want to execute their malware, but I do want to know what their malware is. What is the code they want to execute here? So what we can do, a technique I like to use to deobfuscate code to reveal this bxirp is, hey, instead of executing the code, let's comment that out and let's actually just write it to a file. So I've got a text file path and I'm going to take this same variable and just write it to the text file so we can see exactly what they're executing. And here's what they're executing at the next stage. More Visual Basic Script, and we can see some suspicious strings in here. We can see from base 64, they've got some functions, calling PowerShell, but in a broken up way. Execution policy bypass, so we're definitely on the right track. Down here, they've got a .run to, again, run or execute code. I don't want to run their code, at least not yet. I want to see what they're going to run. So instead of having to figure out all this and deobfuscate it little by little, what I'm going to do is make my own VBS and, again, comment out their run. I don't want to execute or run their code. I want to reveal their code. So let's write it to a file. Again, a text file, and let's take right here this same variable that they were going to execute. Instead, let's write it to my text file. But what happens when we deobfuscate this next stage of the code? You are left with this, a PowerShell execution policy bypass -C for command. They're executing a new PowerShell command. And if we take a look at this giant command here in a new window, just make it easier to read, we can see they're defining a variable up here. They're decoding it from base 64 using this function baseMy, and then again, executing more PowerShell. So they have got layers on layers, multiple stages of obfuscated code. But let's use our trick again. Instead of executing their PowerShell like they were going to at the very end, let's take the same exact arguments, but let's write it to a file instead. I'll set it equal to deobfuscated and then create another PowerShell script and write to it. Because I don't want to execute their code. I want to see what they're executing. I want to analyze it. And what happens when we analyze and deobfuscate this next stage? We are left with this right here, a new PowerShell script. And layer by layer, as we decode and deobfuscate this, we're beginning to be able to read more and more. At this point, the malware is executing PowerShell, but what is it actually doing? Let's take a look. As I usually do, this is pretty hard to read. All this stuff is written on one line. I mean, we can read some of it, but I take it into a new tab and just space everything out, put stuff on new lines so we can kind of read through this. So what is this malware going to do? Well, first, it's going to sleep for 5 seconds. It's going to do nothing for 5 seconds and probably hope that security solutions are going to stop watching it. Next, it's going to test its connection to google.com. Benign website. What it's doing here is testing, can I connect to the internet? And if that ping is successful, if it can connect to the internet, it's going to continue. Otherwise, it's going to force the computer to restart and exit. So the author of this malware has written it to say, hey, if I can't connect to the internet, quit out, restart the computer, exit. Malware authors know that people like me and you like to analyze their malware, figure out what it's doing, and try and stop it. And to protect against that, to evade some defenses for anti-analysis, they do things like this. And further than that, it has another check, get process, to get all the running processes on the computer. And it says if there's a sandbox process, if there's a debugger, if there's Wireshark analyzing the network traffic. This check is basically saying if any of these processes are running, restart the computer, force it, exit out. So it has two techniques in here for anti-analysis and a bit of defense evasion. And at that point, it goes on to declare some variables, declare some functions, run some more code, build some more command strings. What I've done is taken this out and replaced all the variable names with names that make sense. Here is the PowerShell deobfuscated at our current stage. I've removed the checks at the top for pinging Google and for checking running processes. So first, they've got a function baseMy, which all it does is decode base64 strings. Next, in this block right here, they're decoding and saving a URL or a link from this string right here. We can proof this ourselves. Take that base64 string, throw it into CyberChef, and boom. And then finally, they put together a script block to basically load their malware. And this is heavily obfuscated, right? We can see load assembly, invoke reflection. Essentially, they are building a malware loader script and then saving that to JWGXGJXPS1. So essentially, they are building a new PowerShell script that's going to load their malware. Then down here, they're executing that script. So again, what I like to do instead of executing their malware loader, let's run this script, but let's just print out or save to a file the malware loader script. So let's run this script. We do see the PowerShell that they were executing. And remember, this was getting written to a file. They created 3 files, JWGJXPS1, a PowerShell script, and then 2 text files. And we can take a look at all 3 of these. We can look at the first file, which, as we already knew, it's just a URL link to the payload. The second file is the actual payload. So we can take a look at this. This is what is downloaded from the o3.txt website link. This is the payload that was hosted. It's actually a text file of integers separated by commas. And at that, a very long text file. And if we take a look at JWGJXPS1, their actual malware loader that gets executed, we can see a couple of interesting things. And of course, I have taken this out, put it in a new tab, and deobfuscated it. So what they do is define yet another payload link, which decodes to this URL right here. And this ends up being another super long integer separated by commas payload, which is stored as a text file. Then they do a couple of operations. What they do is turn their o3.txt or this VCX text file, they turn this one into a raw payload. First, they read it and get the content and store it as raw bytes. And they split these bytes by the comma. So they read this file as raw bytes. And at the very end, they finally execute their malware payload. And they're doing this in an interesting way. They're actually loading their raw payload as an assembly. Reflective code loading allows attackers to load and execute payloads directly in memory without having to write to the disk. It's a really common way for attackers to execute malware. So they're loading that raw TXT bytes payload as an assembly and then executing a specific method, invoking it with these input arguments. And down here, I have a summary. They reflectively load the assembly of vcx.txt, call a specific type, class library 3, class 1. They pick a specific method or function and run it with a couple of arguments. The link to a new payload, the file path of the local VBS, the location of install-util.exe, which is actually a native signed binary by Windows. It's trusted and legitimate, and we'll see them exploit and abuse this trusted binary. And then the base link to their attacker server. So where do we go from here? User downloads a zip, executes a VBS. The VBS executes way more code and ultimately leads to loading a reflective assembly from a raw payload and invoking a specific method or function from it. Well, just like before, what we can do is instead of executing their malware, we can step in and rebuild their commands, rebuild their code, and see what they would have executed. So let's rebuild their assembly and then analyze that. Instead of executing, let's save it to a file and read and analyze that assembly. So what I'll do is paste in their commands, and we can take a look at the raw payload and make sure it's got the bytes. And there we go. You see, it's just raw bytes. And then I'm going to write all those bytes to a DLL on my system. And we can take a look, and there is the DLL. 03.dll is what I called it. So let's analyze their DLL. We can throw it into detected easy and get some easy hits from it. So it looks like it's a portable executable. It is confirmed a DLL. It's written in .NET. And it is flagged as having anti-analysis, anti-debug protections. So we can use either dnspy or .NET Reflector. We can decompile and take a look at their DLL source code. So I'll go to File, Open Assembly. Let's open up 03.dll, and there we go. We can see class library 3 is loaded in. And if you remember at the execution string, this is what they were executing, class library 3. What I'm actually going to do before we go any further, right click, export this to source code. And I'm going to open up the actual source code in Visual Studio so it's a little easier to read. We'll go into class 3 and then boom, there we go, class 1, the raw C# code. And from here, we can gain a lot of really interesting information. We can see their actual source code, like the actual source code of the malware they wrote that was so heavily obfuscated and so heavily protected with anti-analysis and anti-debug. What I'm going to first do is let's trace and track down PRFVI, the function or the method that they were trying to invoke. So here's their entry point, PRFVI. I'm not going to go through this line by line. There's just too much here, but there's a couple of interesting things we can learn. We can see they're using o1.txt, o2.txt. If we trace this variable back, this is actually the fifth argument being the link to their HostGator website. So they're actually calling 2 more payloads from o1 and o2.txt on that same website. This malware, as we've seen before and we'll see again, has a lot of anti-analysis, anti-debugging. But how do they actually do it? Well, they look for processes. They look for process names right here. And they check if any of the following strings are running processes. So the malware checks, am I running on a machine with VM tools, with VirtualBox service, with VMware user, with Joe Sandbox server? And it's essentially checking, and you can see here, am I in a VM? Is a VM detected? And it's got several other anti-analysis checks like this, checking for MBAM or Malwarebytes, checking for Avast, AVG. All of these are antivirus vendors. And in these lines here, you can see add MP preference. It's actually excluding itself from Windows Defender. Again, using defense evasion tactics, telling Defender, don't analyze me, don't protect me, whitelist me. And they're also checking if a debugger is attached. And again, have duplicate checks again for more processes. Is Avast a running process? Is Python a running process? Is Wireshark a running process? All tools that malware analysis, reverse engineer, defenders, security solutions would be running. What happens if there is someone analyzing this? Well, they run a couple of functions. They run del filler, limpar, and restart. So this first one, del filler, we can take a look and track this down and take a look at what it does. It actually deletes itself. It basically self-destructs. If someone is analyzing this, it runs a command to del or delete itself. Next one, limpar, if we take a look at this one, you can see it actually deletes the entire directory it's working out of. And if we track down what directory that is, we can see it's using this hard-coded directory, app data, local low, Windows system, x86, program, yada, 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 program rules, and video. If it detects someone analyzing it, if it detects a security solution running, it literally self-destructs and deletes all of the files. And the last thing it does is run restart, which, as you can guess, this is a function to force the computer to restart, as we've seen before. So it's really trying to hinder anyone analyzing this malware. After that, it's got functionality to go and download those payloads. We can see it's referencing base 64 %, which is the same thing we saw here in the payload link. It also gives itself a persistent foothold and injects itself into registry run keys, meaning that it's going to run every time the system boots up. So we know that this malware is bad. We know how they're going to run it. We've copied out all the files. We've got their DLL, and now it is time for some dynamic analysis. So what we're going to do is actually execute live their malware. We're going to run this DLL. We are going to execute it just like it would if they ran it. I'm going to run this script right here. Let's open up a PowerShell window and let's take a look at what happens. We had some stuff getting printed out and boom, instantly restarts. So why is that? As I said before, that is because of the anti-analysis and anti-debugging features that the malware has. And if we log back in and take a look, not only did it restart the computer, but it actually deleted its files. It self-destructed. Take, for example, the VCXQS temp path. Let's try and visit that path. If we take a look at what's there, that file does not exist anymore. Can't find the path. As we saw in the malware, if it detects you're on a VM, if it detects you can't connect to the internet, it's going to restart and delete everything. But I've got a way around this. Let's back up. Let's revert our snapshot. And I'm going to run this reverse anti-analysis. So I basically copied their code. I'm not going to go through the script, but I copied all the checks that they're looking for and actually just check for and remediate them myself. So I'm basically just disguising to them that I'm on a VM. So let's run my reverse anti-analysis. You can see I killed some of my VirtualBox processes. I fixed some of the registry keys. I renamed some folders. So now we are going to run their malware live, connected to the internet, execute it all the way. And I've got System Informer set up, which is just a tool to monitor processes because I want to see what's going on with my machine, what's going on with the running processes when I execute this malware. Let's take a look at what it does. So we'll run it, and you can see our computer did not restart. It quits out. Install util. Install util gets spawned, PowerShell gets spawned. So install util was that .NET executable that they are exploiting. So one interesting thing, if we boot up FakeNet, which is going to simulate the internet and capture all the internet requests. And look at this, we can see install util is requesting 167.99.197.25. We can see it's trying to send out data, exfiltrate my data, and connect back to myploto.net. And if we take a look at one of these PowerShell scripts, you can see it's actually running a PowerShell execution policy bypass from that path that we found in the decompiled malware. So if we drill down into app data, there we go. Windows System x86. This is the path that we saw in the malware, and boom, there we go. We have a lot of PowerShell scripts, most of them 1 kilobyte. We've got one giant one. If we take a look at some of these, what are these PowerShell scripts actually doing from the malware? We've got a start sleep and adding a new item property, and it's adding to a certain registry key, which basically gives this malware persistence. So it's going to run every time the machine boots up and the user logs in. It's going to execute PowerShell and execute this VIXEC.ps1. And sure enough, there's VIXEC.ps1. If we take a look at this, this is a much bigger file. If we turn word wrap off, we can see they've got two, again, giant long strings that are seemingly payloads. One of them is super long, and again, it's loading them as a reflective assembly. It's reflective code loading and invoking some of the functions in there. And we can see this ultimate script that has been set up to run every time I log in, boot up my computer. It's got two embedded payloads in it that are raw bytes. One of them we know for sure is an assembly, so safe to say it's probably a DLL, and RLR is passed as an argument. So we don't know what that is, but it's probably binary. But let's take a look at both of those files. Let's take both of these byte strings and let's write both of them to a file. We'll save this as a write files.1. And basically we're just going to take the payloads that they had in their script and write them to a DLL into a bin file. Let's run our script, and then we can see we've got a DLL and a .bin. So let's take a look at what these actually are. We'll fire up detect it easy. Let's take a look at the DLL first. This has obfuscation tags. Looks like it's a VB.net piece of malware, and it was also named something similar. This one was named class 1, which I believe our first one was named class 3. So pretty similar piece of malware. Again, we can open it up in .NET Reflector. There we go, class library 1. And we can take a look at what exactly this is. What kind of code do they have in here? We've got another function here that's got virtual allocation of memory. It's got buffer block copying and then writing to process memory. And if we take a look at what this bin file is, it looks like it's an executable. It's got anti-analysis. It's got obfuscation. It's a 32-bit portable executable, C#.NET. And if we take a look at this one, I'm going to look in dnspy this time, and we can see it's named YM98LZ. If we drop these down, we can see there is a ton of classes and methods and code. There is a lot here. Looks like this is pretty heavily obfuscated. We know that install util is a trusted Microsoft process, right? But we see it reaching out maliciously and exfiltrating data. So if we go back to System Informer, let's go to our install util process. There it is running right there. Let's inspect this and take a look. It's running with a command line that I do not know. It's kind of doesn't make sense. And that's because what they're doing is injecting into this process. They start up install-util.exe and use it as a victim process. They use that trusted, legitimate binary as a space to run and execute their malware. So there is our executable malware payload running in memory, YM98L7. It's running, and we can see it in the .NET assemblies of install-util.exe. And one thing we can try and do to try and signature this RLR binary, the one that's loaded from the script into memory. One thing we can do to signature this heavily obfuscated YM98LZ is look at the human readable strings. I've got it pulled up in PEBear, and there's some pretty interesting strings in here. If we scroll all the way down, a lot of this is unreadable, but we begin to see some strings that are human readable, virtually allocating memory, suspending a thread, maybe to inject into the process. Strings like compile assembly from source, generate executable. This is all really suspicious strings, but it gets better. Keep scrolling down and there's strings for telegram, cotatogram, unigram, telefuel, telegram.exe, discord, discord canary. We've got strings for Steam and Steam path, account name, and right here we even have dcrat-log, dark crystal rat, screenshots, saving screenshots, clipboard, saving the clipboard, information about the antivirus, about the firewall, information about the region, the city, the country name. We've got Discord path, Steam path, Telegram path. I'm not going to dive super deep into any reverse engineering, but we have signatured a version of Dark Crystal Rat or DC Rat. Typical rat, been around since June 2019. It's got the ability to do a lot of different things. Reboot, shut down the system, log off users, clipboard grabber like we saw, execute scripts. It's got denial of service capabilities. Here we go for Steam credentials, taking screenshots, retrieving Telegram and Discord information, getting system info, and obviously maintaining persistence. And of course, the ultimate malware analysis, we can start throwing some of our samples into VirusTotal and take a look at what various security vendors say about it. For example, we can throw in one of the loader DLLs. We can see there's that class library 1 detected as a Trojan, as an injector, because that's what it was, a dropper. There's injector again, inject.net, flagged by 16 vendors. We can also throw in our other hard-coded payload, and there we go. This one is lighting the board up with 46 detections. We've got DC rat, DC rat, DC rat, DC rat, so heavily flagged by a lot of vendors. And that is the full infection chain and attack analysis, deconstructing how a voicemail can lead to Dark Crystal Rat or DC Rat being installed and injected into your computer. Thanks for watching.
I still miss you so.